Okay, this is number 40. What is the mass percent of iodine in a solution containing 0.035 moles of iodine and 125 grams of CCl4? So if you're going to find the mass percent is always equal to part divided by the whole solution. By part, we mean part mass that you're interested in, and so we're interested in I2 because it says it contains I2 in the CCl4, divided by the whole thing. So we're going to have to add the mass of CCl4 to the mass of I2. And so the first step is to find the mass of I2. So the mass of I2 is going to be converting from moles to grams. So here's our moles right here. We need to add up I2 on the periodic table. And if you add that up, it adds up to 253.8 two iodines on the periodic table. Multiplying those two together, we get 8.883 grams of iodine. Now, to find the mass percent, we would take the part that's iodine, which is 8.883 grams, and then divide that by the whole thing. And the whole thing would be 125 grams plus 8.883 grams. So part divided by whole times 100%. And so then take and divide those two guys, multiply by 100 at the end, and we end up with 6.635%. That's to 4 sig digs. I believe there's only 2 sig digs in here, so look to the next one, and if it's 5 or more, round up. So we'd say 6.6% iodine would be in here. All right, the second part says seawater contains 0.0079 grams of strontium ion per kilogram of water. What is the concentration of strontium ion in parts per million, ppm? So parts per million is equal to the mass of the solute divided by the total mass of the solution. So kind of like mass percent right here, except now we multiply by a million, or 10 to the 6th. So the mass of the solute, it tells us, is 0.0079 grams of the strontium. And then we would divide that by the total mass of the solution. And this mass is not going to make a whole lot of difference to a kilogram of water, because a kilogram, of course, is 1,000 grams. And make sure that they're in the same units right here. And yes, we could put 1,000.0079 when we add in the amount of strontium there, but you can see that this is not going to make a whole lot of difference to the 1,000 grams. And so we generally just divide by the mass of the water, because we know that it's such a small amount compared to the water that's there. Anyway, we have to multiply by 10 to the 6th after we divide those two, and after we do that division, we end up with 7.9 parts per million strontium plus 2.